Have you ever wondered how there came to be so many people inhabiting the Earth? It just seems to be growing and growing and growing, non-stop. By 2050, the population of the Earth is expected to reach 9.7 billion people. This enormous amount of people has put a strain on the environment, infrastructure, and operation of society. While the rate of growth is slowing down, the population is still increasing in size. Thomas Robert Malthus was the first person to realize the limit of resources and the dangers of population growth. Malthus believed there were two kinds of checks which kept the population down. Preventative checks are voluntary actions that people take to stop contributing to the population. Positive checks include shorter lifespans, diseases, wars, famines, poverty, etc. With enough positive checks, Malthus believed this would lead to what he coined the Malthusian catastrophe, which forces a population to come back below the maximum carrying capacity of the environment. This led him to create the first equation which modeled population growth. Notice how this function continues to grow infinitely? 4 years after Malthus died, a Belgian mathematician by the name of Pierre Francois Verhulst came along and updated Malthus's population equation. This new equation did not account for the Malthusian catastrophe, but it did model a finite carrying capacity. The logistic equation was modified later to what we see today, and after integrating it, the logistic equation can now be modeled by the function n of t. N of t represents the function. K is the maximum carrying capacity that an environment can support. R is the steepness of the curve. C is some arbitrary constant that is defined with the initial population. And E is Euler's number. Now let's head over to the world population meter. As you look at the graph, you can see the distinct S-shaped sigmoid curve, also known as the logistic curve. As you can see, the projected rate of growth for Earth's population is slowing down significantly as we exceed the 10 billion mark. The question now is, how much longer until we reach our maximum carrying capacity? How much longer until the Malthusian catastrophe destroys the Earth? This function, the logistic equation, has many applications in our everyday life, such as modeling population growth, logistic regression, neural networks, modeling the growth of tumors, chemistry reaction models, Fermi distribution, language change, and crop response, just to name a few.